Hi and hello all. Let us have a look at Oppenauer oxidation. An alcohol gets converted into its corresponding aldehyde or corresponding ketone depending on the alcohol. If the alcohol is primary alcohol, this will get converted into aldehyde. If it is secondary alcohol, this will get converted into its corresponding ketone. Okay. So what are the reagents here? Usually the reagent is aluminum isopropoxide, let's say OIPR thrice. Let me write it a little bit clearly here. OIPR means isopropyl group thrice. So it does not need to be isopropyl or isopropoxy. It could be other groups also. And also need a ketone here. Maybe a cheaper ketone or cheap ketone, so that this will get react with this hydrate on get transferred to this ketone here, and for that hydrate acceptor we need a ketone. As a hydrate acceptor we need the ketone. Here also same case, we can use a ketone like acetone, a cheaper version, or you can use a ketone without any alpha hydrogen atom or so, to avoid certain side reactions. Now let us have a look at the mechanism. Let us write the reagent aluminum isopropoxide. So there are 3 bonds to this aluminum or aluminium depending on which country you are in. So this is aluminum isopropoxide and this is a Lewis acid. Why it is a Lewis acid? Look at aluminum and around it there are 6 electrons. There are 3 bonds. In each bond there are 2 electrons. This compound aluminum is not octet, so it is reactive. Electron pair acceptor is known as Lewis acid. Now, so this acts as the positive center here, while our alcohol, which we need to get oxidized through this reaction, is the negative center. So let's write the alcohol here. And remember there is a hydrogen here which we need eventually to show the hydrate transfer. Now this oxygen has a lone pair and that is the negative center, or it's electron rich, so it can attack aluminum. We can show it through a curved arrow like this. So what does this mean? This means these 2 electrons are going to stay in between this aluminum and this oxygen, or there is going to be a new bond between oxygen and aluminum. Let us show that. In theory, oxygen lost one of its electrons, so oxygen will have a positive charge. When a neutral species lose one of its electron, this will be a positively charged species. And what happens to this aluminum isopropoxide? As there is a new bond is forming here, an old bond can break. So this will break and isopropoxide group will break. So we will have aluminum O, let me write as isopropyl like this to save space, OIPR, isopropyl. And now what? So we have a species like this, and what is left over? This isopropoxy group is, because this bond broke, these 2 electrons are going to stay on this oxygen. What does that mean? That oxygen gets an extra electron. Remember, in this bond, 1 electron belongs to oxygen, 1 electron belongs to aluminum or aluminum. Both electron goes to oxygen. That means oxygen is getting an extra electron. So oxygen is neutral here. So oxygen will have a negative charge. So we can write it like this. This isopropoxy group can pick up this proton. We can show it using a curved arrow like this. And as there is a new bond on this hydrogen, an old bond will break. So we can show it like that. These reactions are all in equilibrium, so we can show an equilibrium arrow here, forward and backward. Here also species lost an H plus, so we can write our species like this. OIPR twice, 2 isopropoxy groups are still on aluminum, and we have a species like this. So this species will interact with the ketone or react with ketone. So this is still a Lewis acid. It does not have 8 electrons around it. So only 6 electrons around this aluminum. So it's still not octet and still a Lewis acid. So our ketone will come into play now. So this ketone has lone pairs on oxygen. One lone pair could attack this aluminum. Let's throw it like that using the curved arrow. And we will have an interesting structure after this. So when our ketone makes a bond with aluminum, we have a structure like this. We didn't assign the formal charges yet. So this ketone this oxygen lost one of its electrons. Now oxygen will have a positive charge. How about aluminum? Aluminum gained an electron because it got one electron through this bond. So aluminum will have a negative charge. So this is called 8 complex. It's an aluminum 8 complex. Now the stage is set for a hydrate transfer from our alcohol species to the ketone. This hydrate transfer is possible, is facilitated by, let's say, this lone pair can come here and this hydrate can transfer here. What does that mean? This hydrogen along with its 2 electrons will go here. Basically a hydrate transfer, right? So this will be facilitated by breaking of this bond, and so aluminum oxygen bond breaks and a new pi bond forms here, and a sigma bond breaks. You can show directly from here to here, that is a curved arrow like this. That also works, doesn't matter, both are equally right. So this hydrate transfer happens, and this pi bond breaks, as there is a new bond is going to be on this carbon, an old bond will break. Otherwise there will be 5 bonds on carbon, so that's not possible. Okay, we can write a transition state, a 6-membered transition state for this transition. Alright, so this reaction. So let us write that. A 6-membered, and its preferred conformation will be a pseudo chair conformation, but for simplicity we can write it like this. The ketone I am writing, so the ketone's pi bond broke, just like we saw in the transition state. So it will be like that, and the new hydride bond, the hydrogen is there. So actually this ketone is getting reduced here. This aluminum oxygen bond broke, and this oxygen is still there, and there is going to be a new bond like you showed earlier, and it's little curvy, sorry about that. And there are 2 R's. It could be R or R dash. It does not need to be a symmetrical one. Anyway, so the hydride got transferred here. So this is the end result of that transition, that reaction. So this is the alcohol got oxidized into a ketone. This is alcohol getting oxidized into a ketone, while this is still tri-isopropoxy aluminum. So we got our reagent regenerated here, and this can go on and do the reaction again. So this is the ketone. Let's basically we can write it like this. This is the ketone we got. So this is basically Oppenauer oxidation. Let us go over this reaction once again. In this reaction, primary alcohol is getting converted into aldehyde, or a secondary alcohol getting converted into a ketone. And for the reagents, aluminum isopropoxide or something like that is a Lewis acid, aluminum Lewis acid like that. It does not need to be an isopropoxy group. It could be ALET twice OET or something like that. Also need a ketone here. In this reaction, this aldehyde will get oxidized, and while this ketone will be converted into its corresponding alcohol. So we saw the aluminum species, aluminum isopropoxide, getting regenerated. After workup, obviously it's going to be isopropanol. So this acetone is getting converted into its corresponding alcohol, that is isopropanol. Here also, actually the acetone part is getting converted into alcohol. So that's an interesting fact. We will come back to this slide later. As a recap, this oxygen attacks aluminum, which is the Lewis acid, and a new bond is forming here and old bond is breaking. So we'll have a structure like this. OIPR minus will pick up this proton, will become isopropanol. An isopropanol is getting eliminated there. Then we will have a structure like this. This is again a Lewis acid. A ketone will get attached to this aluminum or reacted with this aluminum, and then we will have a structure like this. Here a hydrate transfer happens. This hydrate is getting transferred to this ketone species, while this ketone species is attached to this aluminum, and this aluminum oxygen bond is breaking. This a new double bond is forming here, or new pi bond is forming here, and we can show this transition state like this. This is a 6-membered transition state, obviously a pseudo chair conformation. So once this hydrate transfer happens, we have this structure. So this ketone is formed, this aluminum isopropoxide species. This is basically AlOIPr thrice that's getting regenerated. So coming back to our earlier slide. So looking at this slide, you can see a ketone is getting converted into alcohol, while an alcohol is getting converted to its aldehyde or ketone, corresponding aldehyde or ketone. What does this say? So in this reaction, actually an alcohol is getting oxidized into corresponding aldehyde or ketone, while the ketone is getting reduced to its corresponding alcohol. Okay, both is happening. So our desired product is ketone, then we call it as Oppenauer oxidation. If our desired product is alcohol, then we call it as MPV reduction. So obviously that is reduction. Mervin-Pondroff-Worley reduction, MPV reduction. So hope you understood the mechanism of Oppenauer oxidation and MPV reduction, so to say. Thank you.